let's start with today's session. Remember that all the sessions are recorded and they are available in our YouTube channel. We will answer questions at the end of this video. So let's start with Apache Storm Real-Time Analytics. Hello, Scott. Ready to start?
Hello? You hear
Yes, we hear you.
Okay, great. Yeah, I'm ready.
Great. I did make you a presenter, and now I see in your screen. I see the presenter view. Now I see the attendee view. Great, great.
Yeah, I think after 5 of these, I'm starting to get the hang of it.
Well, I didn't introduce Scott. He did 4 sessions already, but go ahead and introduce you.
All right. My name's Scott Shaw. I'm a solutions engineer with HortonWorks. Like Paco said, this is the 5th session. We've talked about a number of different things. So feel free to go onto the YouTube channel and review them. I think there's a lot of good information out there to get you started. And today we're going to talk about real-time stream processing with HortonWorks and Microsoft. So specifically around the Storm product. So I guess let's go ahead and get started. So the agenda for today is we'll have a quick overview of HTTP 2.2. It's interesting to note that in the 5 sessions we've had, we've gone through one version, at least one version of HTTP, and we have another version coming out this month. So this area is moving fast. So it can be difficult to keep up with, but it's exciting technology. Lots of new features and functions coming out. We'll talk a little bit about this data lake solution and how Storm fits into the data lake concept. We'll also have a high-level overview of the capabilities of Apache Storm and why companies choose Storm to implement in certain use cases. We'll talk about the Storm architecture. And then I'll hand it over to Assad, who's the PM for Storm on HD Insight, who will have some really cool stuff around how Microsoft implements Storm in the cloud. And he'll talk things about the Event Hub and also give some really good use cases. And I know Assad has some excellent presentations and demos around Storm on Channel 9, so I encourage everybody to go out and view those. It's really, really good stuff. All right. Oh, and there's the, I wanted to say happy St. Patty's Day to everybody, and also NCAA basketball. So I know people looking at this slide years from now will wonder what the heck a leprechaun with the basketball is doing on a slide deck. But it doesn't have anything to do with HTTP, but just wanted to point that out. All right, let's get started. So if this is your first session that you've watched about HortonWorks, so what HortonWorks does is we do Hadoop. We integrate Apache open source projects into a single distribution called HDP, HortonWorks Data Platform. And this, what this allows too is allows Hadoop to be a viable solution within your data infrastructure. So we provide we provide governance, data governance. We provide data access, security operations, as well as data management. Storm specifically, if you notice, is in the data access portion. So there's a number of ways to access data in Hadoop or HDFS, and Storm is just one of them. There is also batch, which is MapReduce. There's interactive access, which is Hive and SQL processing, which we've talked about in a previous session. And today we're going to talk about the final pillar, which is real-time streaming. Now what we do is, as HortonWorks as a company, we take all the open source projects, 100% open source, we package them, we test them, and we integrate them for you. So each one of those components you see in that diagram has different versions, and we make sure that we grab the most stable versions of each project, package them together, test them, and provide them to you in a distribution. So we also talk about this concept of a we talked about this concept of a data lake, and again we'll see Storm as part of this data lake concept. And the idea is that we see HDFS as a platform for your data your data. So it's not a database. It's not a siloed database. It is a infrastructure platform for all your corporate data. And what we focus on is that companies nowadays are data driven. The data is their proprietary differentiator in the market, and Hadoop allows a company to store all that data into a single location. And what's different about Hadoop and being able to store that data is, unlike a SAN or some other infrastructure hardware, is that you can do analytics on it. So you store the data, and then you have many different ways to run analytics on it, whether it is real-time, whether it's interactive or batch analytics. We also integrate with third parties, such as Microsoft, especially deep engineering relationships with Microsoft that you'll see here and Assad will speak to. We also provide frameworks that enable this integration, such as the Mbari framework, and data management capabilities. So what we'll see, I'll just build this out. Sorry about all the building. Didn't realize it was such a heavy build slide. Now this is a busy slide, but what this shows is the entire data lake architecture. So on the one side you have your source data that come into the data lake or into Hadoop via various ingestion streams, so whether that is Storm or Scoop for relational data or Flume or just NFS mount or web HDFS. There's multiple opportunities and integrations with existing data sources, not just transactional data sources. So that can be whether it's an existing EDW or a file or a RESTful API. You have a choice, and you're not limited to your traditional data sources. As the data is extracted and loaded into HDFS, then you have the ability to apply a model, a schema, metadata on top of that, on top of those files, and then integrate with third-party tools such as Power BI and Microsoft in order to visualize and analyze that data. So we never see the concept of data within HDFS as just a data at rest concept. We try to focus. We envision data moving around your organization, going back and forth through HDFS into your traditional data warehouses, as well through real-time streaming into maybe a text search engine, or into another even into something like a Microsoft appliance APS or something of that nature. But then HDFS becomes the data lake, becomes the primary repository for your data. So where's Storm? So when we look at Storm, Storm is just a small portion of the entire infrastructure, but it's a critical portion for various use cases. In this case, it is a data. It's a data access. It's a data ingestion as well as a data access tool. It's a means to handle data in motion that is constantly running. So some of the key benefits of Storm, which we'll see, is that it is build this out. So basically Storm is, first off foremost, it's streaming. So it's streaming data. It's data that is is in constant motion, unlike a batch data, which is accessed periodically and usually involves large scan processing and takes time to analyze. And unlike interactive, which is it's more human time processing. We think of interactive processing as around the 2-minute range or something, or 15-minute range, or somewhere, some variable around that, more human time. But as far as streaming, streaming is usually considered something that's to be consumed by, both produced by machines as well as consumed by some automated process. It's fast. It's extremely fast. We've seen as many as more than 1 million messages processed per node, and maybe Assad can talk to some of the use cases. We've seen Cisco implement it as a packet intrusion detection, which they analyze 1.5 million packets per second in their storm topology. It's highly scalable. It has a similar architecture to HDFS, in which you have a master and worker node type architecture, so it's highly scalable. It's fault tolerant as well as extremely reliable. So this diagram here shows some of the flexibilities and the ability that once you stream data in from a source, you can move that data into other environments. So Storm doesn't necessarily have to have HDFS as a source. It can run without HDFS as a streaming process. But if you need to persist the data flowing through Storm into HDFS, that's also possible. You could also persist Storm data within any RDBMS, such as Microsoft SQL Server, as well as NoSQL solutions, such as HBase. And at the last webinar, we talked about HBase as kind of a key foundation many times for a Storm architecture. So here's some of the factors, versus batch, and when you would use Storm. Again, it's when you need real-time processing, where that processing has to be done in memory, and then potentially move to disk afterwards. Sub-second, again, always running. Storm topologies. There is a sense of micro-batching, but in many cases, Storm topologies, they are constantly running on data. So there's a continual feed into a Storm topology, and we'll talk about what topology is, that feeds Storm and flows through the system. Usually automated systems are used for Storm, machine-generated data, the IoT type concepts, Internet of Things. And then usually they are also, that same machine or automated process consumes the data. So we have, so Apache Storm is essentially, it's not the only real-time string processing in Hadoop, but it is the most prevalent and the most tried implementation of stream processing. And it has the most use cases and adopters in the field. So it is, the Storm is getting, I've seen Storm just in the past few months really begin to gain a significant amount of traction in the field, because a lot more companies are realizing the value of their sensor data. Seeing a lot of companies, not just manufacturing companies, or oil and gas companies trying to do things like proactive maintenance on equipment to prevent breakdowns ahead of time, but as well as the retail industry understanding the value of clickstream or iBeacon type processing. Think of items like Fitbits and all that streaming health information. This is all ideal territory for a Storm architecture. And in fact, I think the number is about 80% of the data, 80 to 90% of the data being created today is actually from streaming type data and not from your traditional transactional relational processing. So we're seeing a lot of new use cases, again through things like manufacturing, healthcare, taking vital signs of patients, home thermostat data. We're also seeing a lot of pricing data, so price reaction to competitors' price changes in the market in real time. So a lot of cool stuff. And what we're really seeing is less than the more cost optimization type use case that we see in traditional things with like ETL offload and what we'll see in SQL processing. Is the streaming portion really begins to bring in new revenue streams for companies, and they start to get immense amounts of new insights, business insights that drive new revenue using a streaming data process. So really the four key capabilities of Storm is that it is data ingest, extremely high rates of data ingest, the ability to process that data in real time, persistence of that data, whether in HDFS or relational or a non-relational store, as well as operations. So another use case is security, fraud prevention, but there's also the idea that Storm is extremely fault tolerant. It's highly scalable. It is also one of the few real-time streaming processes that guarantees your processing as data flows through. It guarantees that message will be processed. It's also language agnostic, and maybe Assad can speak to this, is that you can code topologies in .NET, and it's 100% open source. So let's look really quick at a high-level overview of what how Storm is architected and some of the key constructs in Apache Storm. So these are the major terminologies you're going to have to get used to when thinking about Storm and building out a Storm infrastructure. So there's the concepts of tuples, streams, spouts, bolts, and a topology. So a tuple is fundamentally a list of values. So think of this as basically a data, like a row. And they can have any number of data types. So in this case, you have maybe an event time, or you have geographical data, longitude, latitude. So that tuple is the fundamental data structure in Storm. It's the smallest component, the lowest granularity you can get in Storm, and that's called a tuple. And a stream is simply an unbounded sequence of tuples. So in a stream, so it's the stream that is what is processed in Storm. And streams come from spouts. So spouts are the data sources. Now a spout can be almost anything. Again, it could be a machine. It could be a sensor generating data. Most likely what we're going to have as a spout is some message queuing source, such as Kafka. So Kafka would sit between the actual data source and your Storm topology, and it would process and filter out the streams as they come through into the Storm topology. And then what happens? The core of Storm is this concept of a bolt. So you have your spout creating the data, and then that is they create tuples that are placed into streams of data that are then sent to bolts to be processed. And so a bolt can process any number of streams. This is where you would do your transformation, kind of your business logic within the stream. It can also, you can spin up multiple instances of a bolt, and it can be dynamic. What we'll also see is that within a single bolt, there are any number of tasks within a bolt. So this would allow, as your stream and your tuples come into your bolts, it would allow for parallel processing, and we'll see how that can be handled. So there's also from your bolts, you can choose to send your bolts to any number of different locations. So this is where you would choose. You'd say, well, okay, this stream comes in and we're going to process the data with the bolt, and at the end of it we'll send those messages to HBase, or we'll send those messages to HDFS, or that's the situation. So consider it like a data flow process, in which the bolt is really the meat of the business logic that's acting upon your stream of data coming through. So it's the decision maker within the Flume architecture. And we combine everything together. This is what's called a topology. So a topology within Storm is considered the workflow. The Apache Storm site compare it to basically a MapReduce job. So this is the if you take all your spouts, your streams, your tuples, and your bolts, and combine them together in a single data flow, then that's your topology. And it's a network that flows together. Feel free to enter any questions into the chat, and I'm sure Paco will interrupt me if there's anything we need to focus on. So some of these outputs here is, for instance, we have an HDFS bolt output. We have a monitoring bolt, an HBase bolt. Now these can be the same streams. You just have the multiple streams going to different bolts for different types of computations and processing. Other outputs include Cassandra, Kafka could also be an output as well as a spout, Memcache, R, JMS, MongoDB, and pretty much any relational database system could also be an output for a bolt. So what are the components, really the physical components within a HDFS cluster? Again, Storm follows the kind of a distributed architecture of both a master server and worker nodes. In this case, the master server is called the Nimbus server, and in the worker nodes, the ones that actually run the spouts and the bolts, are called supervisor nodes. So you would have a single Nimbus node in your cluster, which is the master server, and then multiple, and then each node that you designate for Storm processing would run a supervisor daemon. And then the bolts would, in this case, HDFS bolts would run all the bolts and would run on your supervisors. And you can spread these out in any number of ways for more efficient processing and parallelism. And in fact, as we mentioned before, there is parallelism in the Storm topology, because you have your supervisors which control the work assigned to it. It listens for work, and it spins up a worker process. And within each supervisor, there are any number of workers, which are essentially JVM processes that execute as tasks. So you can, when performance tuning or scaling out your Storm cluster, you would focus on the parallelism and how many tasks are being executed within each within each supervisor process, or within each bolt, actually. And so another concept then, if you have multiple tasks for this incoming stream of data running within each bolt is, and they operate in parallel. One of the things you need to understand is this idea of fields grouping. Fields grouping is just basically telling Storm how these tuples, these streams of data, enter into the bolts. So, for example, if you have 10 bolt or 10 tasks within a bolt running in parallel, you could do shuffle grouping, which just says, well, within the stream, we will send, we'll just randomly send round robin tuples into each task. There's other groupings like fields groupings where you say, well, let's say we're doing a sensor processing off, or let's say we're taking vital signs from hospital rooms or something like that. You could say, well, let's have these hospital rooms go to this task or this bolt, and these hospital room metrics monitoring going to another bolt. So it's a way to kind of partition the data across multiple bolts. And so here's some other, there's all groupings, which is just basically you'll send all tuples to all bolts. You'll duplicate everything, so be careful with that. There's custom grouping, and then there's direct grouping, which the source will actually decide which tuple to send it. So this is just a quick overview of ways that you can scale out and control the processing within a Storm topology. So as we put it together, again, you'll need to know some coding in order to do any of this, to build out a Storm topology. But the documentation is actually fairly good, and it really isn't too hard if you're familiar with just general object-oriented programming. So the first thing is you would create a topology, and then you would build out, you would add your spout to the topology, so you just tell the Storm topology where it's going to get the data from, and then you would build out your, you could also have your parallelism built in there, and then you would create the bolts and add it to the topology. So this is just very, very basic and rudimentary code here. This is based off like building out a we have at HortonWorks, we have a trucking demo which we presented last June at Hadoop Summit, and what it does is it demonstrates how you can use Storm to monitor truck driver behaviors on the road, whether they're braking too fast or driving too fast or changing lanes too often or things like that, and it can feed that in real time into a Storm topology. So you can get instant notification that drivers are misbehaving, and then you can proactively react to that, as well as determine where the drivers are on their routes geographically in real time. And then finally, you would create and submit the topology to Storm. And again, Storm runs as a service, so you would execute the Storm command with your jar file with all the topology in it, and it would just run, and it runs continually, feeds data, monitors, processes that data coming in, and then acts upon it. It is truly real-time event processing. So at this time, that's a really high-level overview of Storm, and at this time I'd like to introduce Assad, who I think dig down more into what Storm looks like within Azure now.
Thanks, Scott. Hi. So yeah, this is Assad Khan. I'm a program manager in Microsoft, primarily focused on Storm, actually now starting on Spark, but let's keep the focus on Storm. So I put together a few slides, so hopefully people can see my screen now. Let me make this small. So Scott already covered in detail about the Storm as a technology. The few of the things which I wanted to cover is like what are some of the benefits that you get once we make it available on Azure. So these are some of the customer promises we have. Let me just get it into the presentation mode. So the first one is the easy setup. The key thing is that
Assad, we're not seeing the attendee view right now.
Okay, let me just do one thing.
But I think we see it okay, so you can keep it in this view if you want. But yes, if you go to presenter.
Can you see it now?
I mean, we see Storm on HT inside, but it is the PowerPoint application as if you were building the slide deck, which is fine. It's fine. You can go ahead and.
Yeah. Okay. Let me start it. Is it better
there we
now?
go. Yeah. Now we see it full screen and the attendee view. So great. That's the way to go.
Okay.
Thank you.
Sorry about that. Okay. So I will spend like 2 minutes talking about some of the benefits for running it on the cloud, and then I will give you a quick demo. So the first is easy setup, which is like we run 100% HortonWorks bits on Azure. The benefit you get is that through few clicks you can build your Storm cluster as big of a size you want. The second is high availability. So what we do is that, as Scott mentioned, it is already fault tolerant and it can recover. The one thing we have added on top of it is that we run 2 Nimbus. So think of it as 2 head nodes for your Hadoop cluster. So if one goes down, we automatically switch to the other one. So as a result, we are able to give you an SLA of 99.9%. The third one is the elastic capacity, something again you will expect out of the cloud, where you can create a 2-node cluster, and if your needs increase, you can go and add more nodes through just a slider, and it has no impact on any of the jobs that are running or the topologies that are running. And again, since it is open source, you have access to all the open source spouts and bolts. We have done a very good integration with Azure. So as Scott mentioned, in Azure, either you can use Kafka as the queuing service, or you can use Event Hub, which is very commonly used when people build apps on Azure. So we wrote the spout, or in other ways the connector for Event Hub. So out of the box you get that connectivity. And then we have integrated into the Azure Portal, so you can get a nice dashboard within the Azure Portal. You don't have to connect to the actual cluster. And the one thing which I will show is the development experience, which shows you how we have helped developers through the productivity by integrating into the Visual Studio. In terms of the programmability, like again, it is a very rich platform. You can use any language. Primarily, we see people use Java. We have full .NET support, which we have enabled, and then you can use Trident. So these are some of, like, from my experiences since we went into the market. So we did a preview in October last year, then we did a GA in February. So these are some of the common use cases I have seen, and type of the inputs people are using, what operators they are using. Again, this is not restricted to this. These are just examples. And then people go and do side lookups or output into different locations, as Scott was mentioning, and then the languages they are using. So basically the only thing I did was, like, I removed the name of the companies, and the rest is actually all use cases which people are using today on Azure. So as you can see, the scenarios are like connected cars, whether you call it connected cars or trucks or anything like that, where the data is continuously flowing through the cars into the cloud, and they then do some operation on top of that. The example could be that the VIN number and the sensor data is coming, then you do a side lookup from HBase, then you can do a machine learning model for scoring, then you can put the output either in MongoDB or DocumentDB and build your end-to-end pipeline. ETL is again one thing which I have seen a lot coming up. ETL is like Storm is a very, very powerful platform. You can do pretty much whatever you want, and at a very large scale. So what people are doing is that even if they want to do push the data into the cloud, they will push through the gateway into the event hub, and then they have a Storm in front of it, which can help them manipulate that data, like refine that data, define schema, and then push it into the blob. So one of the companies, for example, what they do is like they push the data through the gateway into event hub, and they have a small Storm cluster that just converts that data into ORC format. So it is ready for Hive queries in a performant format later on. IoT, very similar to the connected car, and again, like the list goes on, it's fraud detection, social analytics, and many others. In terms of like connected car, this is the project which we are doing with one of the biggest automobile company, and if you go and look at, I have simplified their topology, but basically what they're doing is pushing the data through the event hub into the cloud, and then each circle, the first circle is the spout or the connector, and the rest are the bolts. So in simple terms, bolts are just the operation that you are going and doing on it. So basically they store the data in HDFS so that later on they can do deeper analysis through Hive and others. Then they go and read the reference data from HBase, do scoring from an Azure model, then store the data in document DB, and then live dashboard could be Power BI, SignalR, ProtoS, D3, anything you like. And in certain cases, when they have to go and notify the driver back, they will send the signal back to the car. So just a common example I have seen. This is more of a marketing slide. It shows you the different phases and where Storm sits in the overall picture. So basically, as you heard in the early presentation, there are event producers that are generating events or tuples, and then you collect it through some gateway into the cloud. You push it in through Event Hub or Kafka or RabbitMQ, anything which you want to go and do. Currently, Event Hub is a fully managed service. Kafka you can run on HD Insight through script action, and the rest you can go and run on VMs if you like. Then you can use a Apache Storm on HD Insight, and then you can use ML and other things, and then you can push the data or read the data from many of the persistent storage or NoSQL, or whether it is SQL, and then you can do the dashboarding and push it back into the Event Hub. So a few demos I wanted to quickly show. Let me start by showing you the Azure Portal if people are not familiar. So the first one is, so this is the Azure Portal. If you go sign in, this is what you go and see. Let me increase this. If you want to go and create a new Storm cluster, all you do is like you say new data services HD Insight, and as you can see, you will see Storm in there. You click on it, you give the name of the cluster, the node size, and the password and the storage account you want to connect to, and then you say create HD Insight cluster, and within 10 to 15 minutes you will have your Storm cluster up and running. So these are some of the clusters already up. As you can see, some are Hadoop, some are HBase, some are Storm. So for example, let me click on this one. The few things you will notice is that it gives you the links to get started, how do you build topologies in Java, in Visual Studio, and the scenarios page. You will notice few links on the top. If you go and click on the scale, you will see this is a 4-node cluster, and I can hold this bar and keep sliding all the way, and I can create like a 550 node cluster if I want. And again, it depends on my subscription. My subscription, if it allows even more than that, you can go up. And at this point, if I go ahead and save it, it will charge a lot of money, but you will have a very, very, very large Storm cluster. So for now, I will discard it. And as I said, like if I have some topologies running on this cluster, there will be no impact on that thing. So that shows you the scalability that you get. The other one is that you will notice that Storm cluster has the link to the dashboard. This is where you can, sitting from the browser, you can go and submit your topologies. So we have some starting topologies like word count, trident, and all of that. So for example, if I say word count and I say submit, at this point it take this jar file, submit it to my Storm cluster, and that will start to run. So as soon as this submission finish, the result will show up that the topology has been submitted and it is running. So now it says that now it is active. Now I can go and click on the Storm UI, and I can go and monitor that Storm topology which I just submitted, which is the word count. I can go kill, rebalance, deactivate. So the key thing for us is that we, and this is the reason we partner with HortonWorks, is that we want to make sure that we are running the full open source bits which are available on the cloud. The key thing we enable on top of it is like what are the benefits that comes with the cloud and integrating with other assets that we have on Azure. So this is the same Storm UI dashboard that you will go and see if you connect to your cluster. All we have done is taken that thing out and put it on the web. And again, with the new version of the Storm, all this monitoring is available through the REST API, so you can go and build your own fancy dashboard. So again, it shows the richness of the platform and how it is ready for enterprise use. The last thing I will go and show is the Visual Studio experience. So what we have done is that if you go and download the Azure SDK 2.5 version, which is the latest one, it comes with full support for Storm. And what I mean with that is that building this topology requires, like, especially if you are a .NET shop, to either understand Java and like download all the dependencies and all of that. All of those scenarios are still supported, but for Microsoft customers who are the .NET shops, what we have done is that you can go and say new project, and one thing you will notice is that on the left, if you click on HD Insight, you will have Hive application, Storm applications, a Storm starting sample. So this is something like a quick Hello World program. You can get started and you can just it will just build and run, or you can have the Storm application, which is an empty one. So the hybrid one is interesting. Basically what happened was that as we enable the .NET experience, there is already a big ecosystem of connectors out there, or the Spouts, which are available to connect to Kafka, and the one which we wrote for Event Hub. The problem is that if I'm writing in .NET, now I need a .NET connector. And either we go and replicate the entire open source ecosystem and have a replacement in .NET, which is very hard to go and stay up to date with the open source community. So what we have done is that we have enabled this hybrid mode where part of your topology can be in Java, the rest in .NET. So you can use a Java spout to go and connect to Kafka, let's say, and then you can write the bolts, which are the operations, which also have your business logic all in .NET. So again, like the spout that we wrote for Event Hub is in Java, but all customers who are using .NET just use the same spout. So the other thing which we are doing is that we are adding templates online so that you have a really easy way to go and start building apps. So for example, if you are doing social analytics, we have a Twitter starting app. It has two parts to it. One is the front end, just to show you the end-to-end scenario, and then the one which is the topology. So the front end is built in SignalR. SignalR is a very common technology out there for ASP.NET. The reason it helps for real-time scenarios is that rather than a pull model, it has a push model. So you can push the data to the website, and then you can have nice dashboarding and all of that. So if you go and click on that thing, you open the app and you just say right click and publish, and you will have a very, very simple front end sitting. So I will show you. Actually, I opened it here. This is the app. Again, like we wanted to keep it simple. People can go and modify. Since this is the front end for the social, it shows you the number of tweets coming in and what are those tweets. So now let's connect to actually the Twitter API and pull the tweets and then display it based on the subject which we want to go and filter on. So to give you visually, what we are doing is that we are building a topology. There are Twitter streams coming in. There's a Twitter bolt, then there is another bolt that writes it to SQL, then there is a bolt for SignalR which pushes it into the website. So what I will do is I will click on the Storm Twitter sample and I will say OK. At this point it will give me the basic scaffolding needed for building my social analytics app. You will see that there is one spout. This spout is the Twitter spout, which directly connects to their APIs using the client API that Twitter publishes. It has bolts. It has a bolt that pushes the data into SQL. It has a bolt to do any operation I want to do on tweets, and then there is a bolt that does that pushes it to the SignalR. The only thing is, since it's a template, the only thing it asks is like, for what is your config file? Like, what is your Twitter dev key? What is your SQL connection? What is the website you want to go and push the data to? So I put it in an XML file. I just copy paste that thing in here. So now with that thing, I just save this one, and you will notice that I don't need any dependency on this machine. At this point, it will go and download the NuGet packages it needs for building my thing. So it will go and actually it partially builds at this point. The rest, it requires the Storm dependencies. So we deploy it to the Storm, and then it will build and run over there. Now the thing is that how do I go and deploy it? So one of the options that I showed you is that through the website or the dashboard, you can go and deploy topology or submit topology. But since you are in the Visual Studio environment, our goal was that you don't leave this environment. So if a developer is in there, they can do everything from the Visual Studio. So if you go to your app, you can go and right click, and one of the options that you will see on the top is submit to Storm on HG Insight. So if you click on that, we already have your subscription that you used when you signed in into the Azure SDK for VS. So now we can see all the Storm clusters that you are running under this subscription. So these are some of the Storm clusters that I have. I created for one of my colleagues, Scott, a demo cluster. I can go and use that one. I select this and I submit. At this point, they take the project, they use the API to go and submit this to the Storm cluster, and then once it is submitted, it will go and start to run. And when I say it runs, what it will do is it will start pulling the data out of the Twitter API live and show you all the tweets that are coming in. So it just takes a while before the topology starts to run. But like the thing is, like, what tweets will come? So I can go and decide that. So if you go and look at my spout, which is the connector, I just said get all the tweets that are on Strata and Microsoft. And again, this template was written a while back when we were doing the GA at Strata. But you can go and change anything. So if you go and say SQL, it will actually show you all the tweets that are happening right now at SQL. So let me see if the tweets start to come. So as you can see, the tweet starts to come. Every tweet that either talk about Strata or Microsoft is coming. And these are literally the tweets happening right now. Like if someone goes and tweets within 2 seconds, it will go and show up. Again, it's not a fancy dashboard. The key thing was to show you the end-to-end. Now if you say that, oh, I want to go and customize these things, so you can go and say, first of all, I can show you where it is. So basically this is the cluster. I can say view Storm topologies, and these are the two which I submitted. First was the word count, and this is the one which I just submitted. So it will show you your entire topology. Again, sitting within Visual Studio, you can kill the topology, rebalance, activate. You can go further down. You can look at the spouts and the bolts it has in there, and then you can come back and let's say if I want to go and stop this topology at this point, so I kill the topology and it will go ahead and kill this topology. And let's make one modification in there. So as you can see that there's a bunch of tweets that are coming in English and some are in other languages. What if I want to go and change that? So I can come here open the bolt. Again, as Scott mentioned, bolt is the where you do the operation. So I can say if tweet dot language is English, then it will go and display it, otherwise it will not display. So if I go and resubmit that thing and go through the whole process, it will only show me the tweets that are in English. So again, this shows you the power of Visual Studio, where you have the fully typed system, strongly typed experience. You have the way to monitor, to go and deploy. What if you want to add another bolt? Again, you can go and say add new item, and once you click on the new item, it will show you the storms and bolts. And our intent is that over time we want to go and add more specific bolts. So rather than a general bolt, you can actually say a SQL write bolt, SQL read bolt, H-based read bolt, write bolt, document DB read write bolt, windowing bolt, because we can go and build those templates, and then you can go and customize. Right now, if I go and say storm bolt, it will create an empty one. It will leave the execute method for me, so I can go and write my business logic. So in summary, this is what we have done. Again, it is the same storm bits that HortonWorks produces. We run it in the cloud. As part of running into the cloud, there are a lot of benefits that you get out of it. You get the Azure Portal. It is easy to go and deploy. You get scalability and elasticity. You get the dashboard, and you get the Visual Studio experience. So I stopped a few minutes before the finish time to make sure that people have, I don't know, like, do we do Q&A or like?
Great, that was really fast. I will make sure we have you in future meetings, okay, to go in detail.
Yeah, sure.
Thank you very much for being here. Thank you, Scott, too. Is there anything else you want to present, or can we go to questions?
No, I think we should go to questions, Paco.
Great. You can see them on the question pane. I will read it for you. There are not many, even though this was great content. So one question is, why do we need different bolts, like HDFS bolt, H-base bolt? Why can't we process everything in a single place?
Yeah, I can address that real quick. Well, it's because you may want to do different things with your data. You know, there may be so as data's flowing through the topology, you may want to fork that data for different purposes. So you may have a layer that streams the data for real-time fraud detection or monitoring detection or something like that that feeds into an alert system. So you get instant alerts. But then at the same time, you want to branch that same stream off of tuples into a more persistent store, such as, you know, document DB or HDFS for maybe long-term analytics, maybe for machine learning or trending dashboards, or to run Hive SQL queries against it, or store it in SQL Server. So it's the flexibility of what you're doing with the data, applying business logics based off different use cases. So in a sense, you are still handling the same stream of data. You're just doing different processing on that same stream of data.
Great, thank you very much. Another question is, if my source is a huge file and I have created multiple spouts, what exactly is the behavior? Is that something like each spout will be reading a specific portion of the file, or each spout works independently of each other?
So we're talking about streaming data. So we aren't reading from files in this case. So for instance, if we are reading from a file, we may be reading from like an application log in which there's we're running a tail on the log. So the log is constantly generating data, and we're just feeding that data into the stream topology. So we aren't looking at a large file and just reading a file. This data is in motion as it comes into the topology. For the large file reads and things of that nature, you're probably going to want to use a different method. And feel free to break in, Assad, if you have any other ideas. But that's really Storm. Storm is built around real-time event streaming.
Great, thank you. Well, fantastic demo, worth watching. One quick question, what is C# hybrid?
Yeah, so I can take that one. So as I mentioned during the demo, the key thing is that there is a big, so if you are building your topology, like most of your business logic and what you want to go and do with that data comes in the bolts where you do the actual operation. Spout is just a connector to connect to the source, and Spout is actually quite a bit of work because you need to go and understand how that queuing service works, how the replay will happen, and all of that. So basically, that's where the whole power of the open source comes in, because you can pretty much find Spout for everything out there. And we did not want to lose that edge of like where people can go and pick any Spout. So basically, what I mean by hybrid was that you can use the Spout from the Java Spout, which can connect to your queuing service or your source, and then you can build your downstream bolts or the business logic in .NET. So through this mix of the Java and .NET, now you have the best of the both worlds, because for most part you don't need to go and touch the Spout code. So it's for you it's a black box. It will bring in the data, and then you can do the operation through the bolts.
Thank you. Great. Are most Storm implementations internal or cloud?
Well, Storm just recently came out in Azure, so I think we'll see. Actually, Assad, when did Storm go live in Azure?
Yeah, so we released it in October as a preview, and at Strata last month in February we announced the GA. So yeah, I think the answer is that basically Storm gives you the capability for real-time analytics. Storm itself will not make you decide whether you want to go on-prem or in the cloud. Like, you have made that decision way before that. Like, it is your installation, even for Hadoop, as Scott was mentioning about your data lake. Is it a cloud-generated data? Is it on-prem? The requirements of your company, like, do you want to go in and embrace cloud, or you want to be on-prem? The key thing is that it's the same capability. It's up to you as a business owner to make the call whether you want to go with cloud or on-prem. I don't think it's the Storm that will force you one way or the other.
No, but I will say I definitely see cloud adoption increasing, and we do have a number of very large Storm, or not necessarily large, I mean around the 30-node cluster type size, but extremely high revenue topologies running that for companies that are running in the cloud.
Yeah,
so,
I agree.
Yeah, so I'm seeing across the board cloud adoption increasing significantly.
Thank you. Does SSIS have any hooks into Storm? Integration services?
I don't believe so. No, not at this point. Right. So no. So there aren't any data flows or options in SSIS that I know of right now for Storm.
Okay. There is another question that is what about analysis services?
So,
I mean, we can go ahead and say that because from SSIS we can connect to Hive and HDFS, and this is somewhere where Storm can work with. There is an easy way to build it, but not a default connector, right?
Yeah, I think like one thing which I have noticed, especially with our customers, is that the one thing which they love about Storm is the flexibility, because it's pretty much in the bolt is the code which you are running. So basically, if I'm connecting to SQL, all I need is a SQL client, and I download that client, and then I can make the call from there. What Storm gives you is that running it at a very large scale and scale out, and then you can go and even as Scott was mentioning, like how the data is flowing between the spouts, and how you want to even scale one bolt as compared to other. You can give it more executors and more slots, so that if that is the bottleneck, you can come over it. Otherwise, Storm, like people do crazy stuff, because the thing is that there isn't anything which restricts you. So basically, if you want to go and try out, like someone did a demo and shared it with me, where they said, oh, like Power BI now has a REST API. So I wrote this bolt that takes all my data and pushes it into the Power BI dashboard, and now I have a live dashboard working with Storm. So great, like we did not provide it out of the box, but you can go and write that thing.
Yeah, and keep in mind, Storm isn't a data store. It's an event processing. So it's not like you'll store data in Storm and then access it via some mechanism. Storm will process data, and then it can send that to other sources, such as SQL Server, for further analytics, if you want. Or it can read from other sources and apply, like, lookups. Sometimes HBase is used a lot for really fast lookups against the streaming process in order to do some kind of decision tree type mechanism against the topology. So, but Storm itself isn't a persistent data source. That makes sense.
Thank you. And last one, I don't know if you want to go and would you discuss security to the data lake? Anything you can add to security related to data lakes?
Well, I think that's a larger discussion. So obviously, Azure's a very secure environment. As far, HD Insight's going to be secure for you. HDP as IaaS in Azure is going to be secure for you. On-prem HDP, we distribute a number of Apache open source projects around security, including Nox for gateway security, Ranger for more centralized security and auditing. There's encryption options in HDP, SSL, things like that. So we've, as a company, we focus very strongly on security, and actually Hadoop is implemented in some of the largest financial and banking institutions in the world, and they're obviously very concerned about security. So that's a larger discussion that we can take offline.
Okay, thank you very much for coming to this session, Apache Storm Real-Time Analytics. Thank you, Scott, and thank you, Assad, for presenting today. Remember that you can watch the recording of this session in our YouTube channel. You can check the link for the YouTube channel on bigdata.sqlpass.org. We will announce our next session soon. Remember to fill the post-event survey to enter the raffle for three $50 Amazon gift cards. And if you did attend the last 4 sessions and this session for the educational webcast from HortonWorks, you will enter the raffle for a GoPro camera. Well, that's everything for today. Thank you very much for attending.
Okay, thanks for having us.
All right, thank you.
Thank you.